Hi everyone, welcome to iProcess webcast. My name is Roxana and today we will talk about hardware. We have a guest, our friend and hardware consultant, Tom.
Yeah.
Hi, Tom.
Hello everybody. Tom Billsbury here from Haywire.
So in the software world, we do iterations. So
Yes.
I do it as little as I need it for now.
Mm-hmm.
Maybe I need more detail later in the next iteration and so on. But can we do the same with hardware?
It can happen where basically, as long as the whole thing doesn't get torn up, like there's not this huge major change, you can iterate on at a specific hardware level with a decent level of detail. But it's definitely not as malleable as software, because the thing is, like, once the hardware pipe travels down the chain, it's pretty fixed. You can make small changes, and the folks that can make drastic changes deep in the design process are the ones that do well. And that's Haywire. We're really good at that, down deep in the hardware design process, make a change. But then we also aren't restricted. Like, we don't have to go back up and make a bunch of changes to a spec either.
Right.
So there's a trade-off between agility and the
completeness
hardware.
kind of.
Correct.
That makes sense. So how would you ensure this traceability? Because in a software world, you always have tools that are linked to other tools. Is in hardware the same?
Yeah, so in hardware, the later software packages now on a lot of the CAD tools not only have revision handling, but they also can integrate into GitHub. And so you can effectively use a GitHub type tracking with branches and notes.
For hardware too?
For hardware, yeah.
So a second process from ASPICE is to have hardware design. And I think this is like a bigger umbrella, and they say you need to specify those requirements into hardware architecture. Then you need to specify hardware detail design. Then you need to have specified dynamic aspects, and then analyze the hardware architecture and the detail design, and then again traceability to specs, and then to communicate.
Yeah, and that's very much the flow. So like of a typical hardware design flow, you want to make sure the architecture is set, the high-level system architecture is right, and then from that you can develop, well, what does the system look like? You can define architecture pretty quick, and you can break that out into, here's team A, B, C, D, let's go do this pretty quick. But then actually managing that with changes as you're developing, because nothing's really like set in stone.
Which is fine.
Yeah, which is fine. Yeah. And then also, you want to trace what you're doing, so that comes back to that revision control. And then you want to, communication is actually a big pillar of that.
And then there are two other processes that is about verification. So one, they said we need to verify against the design for hardware. And they say you need to have methods and measures, specify verification measures for verification against design, then ensure compliant samples, then select verification measures, verify, obviously you need to execute on those, and then traceability again, and then summarize and communicate results of the verification.
Yeah, testing verification is a big component. So not only verifying that the hardware does what your design intended it to do, but to also make sure that your hardware is operating how the ultimate customer wants it to operate. And they can be two different things sometimes, because you could have, like, for example, circuits on a board that operate other internal circuits, and you need to verify that is working, but that might not actually affect the customer at all. So there is definitely a verification process, corner cases, and testing and verification can actually be more work. Often is more work than the actual design.
Be. I don't know, there is a misconception that I have months of development and then a couple of weeks of testing or verification. That is not the right approach.
Right.
Okay, so these are the new processes added in ASPICE. Do you see anything that is not good engineering practice from hardware perspective?
No, I think the practices are great. I think for companies that follow such a process, I think it's great to
have something, right?
Move through. Yeah, for sure.
Nice. I have to ask you a question. What is this new concept of hardware agility?
Being agile from a hardware perspective, from my perspective at Haywire, is to be able to, if a customer or client wants to make a change, that there's not this huge adder on cost. They can basically, and there's not a huge time adder. Basically, the design is done in a way through keeping circuits modular. It's making sure that you can make a change without a big cost or time investment from your client who you're serving.
Yeah. Oh, I really like it. I'm a big fan of modularity, even in software. And when you design your system, you need to think about this, right? Okay, awesome. I think this was really good. Thank you.
Okay, yeah.